equation's roots, we have to find what the nature kind of the roots have. And if there are real roots, we have to find the roots. So in that number 1, 2x square minus 3x plus 5 is equals to 0. On comparing this equation with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Putting this value of a, b and c in equation b square minus 4ac, we get minus 31 answer, which is less than 0. So b square minus 4ac is less than 0. So no real roots exist here. Number 2, 3x square minus 4 root 3x plus 4 is equals to 0. On comparing this equation with ax square plus bx plus c, we get the values of a, b and c. Similarly, we put this value in the equation b square minus 4ac and we get the answer 0, which means two equal real roots exist. So we will use the quadratic formula x is equals to minus b plus or minus under root b square minus 4ac upon 2a. X is equals to minus of minus 4 root 3 plus or minus root 0 upon 2 into 3, which is equals to 2 by root 3 and 2 by root 3. Two equal real roots exist. In number 3, 2x square minus 6x plus 3 is equals to 0. And comparing this equation with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Putting this value in the equation b square minus 4ac, we get the answer 12, which is greater than 0. So two distinct real roots exist here. Using the quadratic formula, x is equals to minus b plus or minus under root b square minus 4ac upon 2a, and putting the values in it, we get the answer 3 plus root 3 by 2 and 3 minus root 3 by 2. In question number 2, we are told that there are two equal and real roots exist of this equation, which means that the discriminant is 0. Means b square minus 4ac is equals to 0 and we have to find the value of x. So we will compare the equation 2x square plus kx plus c is equals to 0 with ax square plus bx plus c is equals to 0, and we will get the values of a, b and c. We will substitute it in the discriminant formula b square minus 4ac is equals to 0. And we get the value of k. Here b square minus 4ac is equals to 0. We have right here 0 because it is told that two equal real roots exist. So by substituting the values of b, a and c, we get the value of k equals to plus or minus 2 root 6. Similarly, in number 2, kx into x minus 2 plus 6 is equals to 0 is given. We will multiply it and making it the quadratic form. Kx square minus 2kx plus 6 is equals to 0, and compare it with ax square plus bx plus c is equals to 0, and we will get the values of a, b and c. Now we will substitute this value in b square minus 4ac is equals to 0, and we get the value of k, which is equals to 6. In question number 3, we are told that is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square, and if it can be designed, we have to find the length and breadth of that mango rectangular grove. We have supposed that breadth of rectangular grove is x, then the length of grove will be 2x and area is given 800 meters square. So x into 2x is equals to 800. Rectangular's area formula, 2x square is equals to 800. 2x square minus 800 is equals to 0. This is a quadratic equation form, and now we will compare it with ax square plus bx plus c is equals to 0, and we will get the values of a, b and c. We will substitute this value in b square minus 4ac formula and get the answer 6, 4, 6,400, which means that two real distinct roots exist. Using quadratic formula, we will find the roots of x. Minus b plus or minus b square minus 4ac upon 2a. Substituting the values of b and b square minus 4ac and a, we get the answer 20 and minus 20. But length or breadth, any length cannot be possible to be negative. So 20 is the correct answer. So the breadth of the groove is 20 meter and length of the groove is 40 meter. In question number 4, it is given that is the following situation possible? If so, determine their present ages. We have to find that the situation is possible or not. And if it is possible, we have to find the present ages of them. The situation is given, the sum of the ages of two friends is 20 years. 4 years ago, the product of their ages in years was 48. Suppose the age of one friend is x years. Then the age of another friend will be 20 minus x years, as the sum of both of them is given 20. 4 years ago, the age of one friend was x minus 4 years and another friend age was 16 minus x years. X minus 4 and 20 minus x minus 4 is 16 minus x, and the product was 40. So x minus 4 into 16 minus x is equals to 14. We equate it and bring it in the quadratic form, x square minus 20x plus 104 is equals to 0. And now comparing it with the equation ax square plus bx plus c is equals to 0. And we will get the values of a, b and c. Substituting this value of a, b and c in equation b square minus 4ac, we get the answer minus 16, which is less than 0, which means no real roots exist here. So this situation is not possible. In question number 5, it is asked that is it possible to design a rectangular path of perimeter 80 meter and area 400 meter square. If so, find its length and breadth. We have supposed that length of a rectangular path is x meter. Then its breadth will be 40 minus x. Because the formula of perimeter is 2 into L plus B. We have taken L as x and perimeter is given 80. So B is equals to 40 minus x. So breadth will be 40 minus x and area of the path is 400 meter square, which is given. So length into breadth, x into 40 minus x is equals to 400. By equating it and bringing it into a quadratic formula, x square minus 40x plus 400 is equals to 0, and comparing it with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Substituting this value in b square minus 4 is a discriminant formula, we get 0 answer, which means two equal real roots exist here. Means this situation is possible. We will find the roots by quadratic formula. X is equals to minus b plus or minus b square minus 4ac upon 2a. Substituting the values, we get 20 and 20 meter answer, which means that length and breadth both are 20 meters of a rectangular path. Here we have completed our exercise 4.4 and chapter 4.